Now I'm ready to collect the data. Uh, so this is the first trial. In this trial, I'm going to keep the mass hanger 75 centimeters above the lab floor. So this is my ruler. I'm going to use that to measure the height to the mass hanger from the floor. And now you can see this is at 75 centimeter position, and that is the height to the mass hanger from the floor. And also I will note down the left edge of the card, which is at 25 centimeter position. Then I'm going to release the card from this position, and I can measure the velocity of the card when it is moving down the track. And I'm going to collect the data of the final velocity of the card, or the velocity of the card when the mass hanger hit the ground. In the next trial, I'm going to set the initial height to 65 centimeters from the floor. To do that, I'm just going to change the position of the card so that the left edge of the card is coincide with the 35 centimeter position of the track. Then I know the height to the mass hanger from the floor is 65 centimeters. So that I'm going to change the height to 6 different heights: 55, 45, 35 and 25 centimeters. For each height, I'm going to get the final velocity of the system when the mass hanger hit the ground. Alright, so let's get the first data point. So the left edge of the card should be coincide with the 25 centimeter position of the track. Then I know the height the initial height of the mass hanger, or the height to the mass hanger from the floor, is 75 centimeters. Hit record and release the card from 25 centimeter position. Stop recording data, and this is the position of the card as a function of time, and this is the velocity of the card as a function of time. So we need the maximum velocity. The maximum velocity is the velocity of the system when the mass hanger hit the ground, or just before the mass hanger hit the ground. So I'm going to use this tool. The name of the tool is add a coordinate tool. So I'm going to use that tool to get the final velocity of the system, or the velocity of the mass hanger just before it hit the ground, and it is 1.53 meters per second. So I'm going to open my Excel sheet. The velocity is 1.53 meters per second. Okay, so here's my Excel sheet. The height of the mass hanger is 75 centimeters, and the initial speed is 1.53 meters per second. Similarly, I'm going to get the velocity of the mass hanger just before it hit the ground for all these initial heights. Okay, now let's collect the data for 65 centimeter position. So go to the Pascal, and I need to set this to 65. So I know if I bring this card to 35 centimeter position on the track, the height to the mass hanger from the floor is 65 centimeters. Now hit record and let it go from 35 centimeter position. Now stop collecting data, and that is the velocity we need. So go to the velocity graph and get the maximum velocity of that float. So use that tool, add coordinate delta tool. The velocity is 1.41 meters per second. So go here, 1.41 meters per second. Similarly, get all the final velocities. Then you can calculate velocity squared, initial energy of the system, final energy of the system, and then you can compare the ratio between these two energies. The mass of the mass hanger is 105 grams or 0.105 kilograms, and mass of the cart is 0.4987 kilo. When you see this table, you will have all the data, so you can do the calculations.